Your SQL query works, it gives the correct result, but it takes forever. And this is where many people get confused because they think if the query is correct, then the query is good. But in real data engineering work, that is not enough. A query can be logically correct and still be very expensive. It can scan too much data. It can join tables in the wrong way. It can create duplicate rows. It can ignore partition filtering. It can make dashboards slow. And it can increase compute cost. So in this video, I will show you 5 common SQL performance mistakes and how to think about fixing them like a real data engineer. Hello everyone, welcome to Big Data Factory. I am Pranit and have over 4 decades of experience working as a data engineer. If this is your first time visiting this channel, don't forget to subscribe for more content on big data and real world insights. Now let's start with one important point. SQL performance is not about memorizing tricks. It is about asking better questions. How much data am I reading? Am I filtering early? Is my join increasing the count? Am I using right columns? Is this query engine able to optimize this query? So whenever your SQL query is slow, don't just ask, why is this query slow? Ask, what is this query forcing the engine to do? That mindset changes everything. The first mistake is using select star. Now select star looks harmless, and for quick exploration it is fine. But in production queries, dashboards, ETL jobs, or large tables, it can become expensive. For example, select star from orders. This query reads every column from the table, but maybe you only need 3 columns. Select order ID, customer ID, amount from orders. This is cleaner and more efficient. So why does this matter? Because many large tables have dozens or hundreds of columns. Some columns may be large strings, JSON fields, metadata columns, or nested data. If you select everything, the engine may need to read and move more data than required. So the rule is simple. Don't read columns you don't need. A good data engineer is not just thinking about the result. They are thinking about how much data was scanned to produce that result. The second mistake is filtering too late. Let's say you have a large orders table and a customer table. You write something like this. This may work, but from a performance thinking perspective, you should ask, can I reduce the large table before the join? A cleaner pattern is this. Now the intent is clear. First, reduce the large table, then join. Some SQL engines are smart and may push filters down automatically, but writing the query clearly helps you reason about performance. Especially in data engineering, where you work with large partition tables, the filter condition can help the engine read only relevant partitions. So the key idea is filter early, reduce data before expensive joins and aggregations. The third mistake is one of the most dangerous ones, wrong joins. Not just because they make queries slow, but because they can also make your answer wrong. Let's say you have two tables, orders and order items. Now, if one order has 5 items and you join orders with orders items, that one order becomes 5 rows. So if you write below query, this query may look correct, but it can overcount order amount because the same order amount is repeated for every item. So the query is not only slower, it may also produce wrong business metrics. That is why before every join, you should ask, what is the grain of table 1? What is the grain of table 2? Will this join increase my row count? A better approach is, if you want customer level order amount, aggregate from the orders table directly. Or if you really need item level logic, aggregate at the correct grain first, then join. So the key takeaway is, slow joins are not always just performance issues. Sometimes they are data modeling issues. Wrong grain creates slow queries and wrong numbers. The fourth mistake is using functions on filter columns. For example, this query looks simple, but in many SQL engines, wrapping a column inside a function can make it harder for the engine to use indexes, partitions, or pruning efficiently. A better pattern is this. This keeps the original column untouched, and it gives the engine a cleaner range filter. This matters a lot when order time is indexed, partitioned, clustered, or used for pruning. Same idea applies to other cases also. For example, instead of this query, you may want to store normalized email values separately or handle normalization earlier in the pipeline. The main idea is be careful when applying functions directly on large filtered columns. because the query may still work, but the engine may have to work harder. The fifth mistake is guessing instead of checking. Most people look at the slow query and start guessing. Maybe the join is slow. Maybe the table is big. Maybe the filter is bad. Maybe the database is slow. But data engineers should not only guess, they should check the execution plan. In many SQL engines, you can use explain select, or in some systems, explain analyze select. The exact syntax depends on the database, but the idea is the same. The execution plans tells you how the engine is actually running your query. Is it scanning the full table? Is it using a filter? Is it doing a broadcast join or shuffle join? Is it joining in an expensive way? Is one step taking most of the time? Is the row count exploding after a join? This is especially useful in Spark SQL and Databricks also, because the physical plan can show you operations like scans, exchange, joins, aggregations, and shuffles. So the rule is don't guess performance problems. Inspect the plan because the execution plan shows what your SQL is really asking the engine to do. One bonus mistake, using distinct as a quick fix. Sometimes people get duplicate rows after a join and they immediately write select distinct. This may hide the symptom, but it does not fix the root cause. If duplicates are coming from the join, you need to understand why. Is the dimension table duplicated? Is the join key not unique? Or is joining at the wrong grain? And are you missing one condition in the join? Distinct can be expensive because the engine has to compare and remove duplicate rows. So don't use distinct blindly. First understand why duplicates are happening. Then fix the join of the grain. Use distinct only when it is logically required. Before we recap, here are a few additional SQL habits that can help performance in the right situations. Use limit when you are exploring data and don't need the entire dataset. If you don't need duplicate removal, prefer union all instead of union because union has to perform extra work to remove duplicates. Use CTEs to make complex logic easier to understand and debug. And use window functions when they solve the problem naturally instead of creating multiple self joins or complicated subqueries. Now, these are not just performance tricks that makes every query faster. The real goal is to write SQL that is easier for both humans and the query engine to work with. So let's quickly recap the 5 SQL performance mistakes. 1. Avoid SQL star in production queries. Select only the columns you need. 2. Filter early. Reduce large datasets before joins and aggregations. 3. Understand join grain. Wrong joins can create row explosion and wrong metrics. 4. Avoid wrapping filter columns in functions when possible. Use clean range filters. 5. Check the execution plan. Don't guess why the query is slow. And bonus, don't use distinct to hide bad joins. The main takeaway is this: SQL optimization is not about writing fancy SQL queries, it is about reducing unnecessary data movement, avoiding row explosion, and helping the query engine do less work. A good SQL query is not just correct, a good SQL query is correct, readable, and efficient. If this video helped, comment SQL. I will make another video on production level SQL optimization with real interview questions. Drop a like, subscribe to Big Data Factory. This is all for today. I will see you in the next video. Till then, keep learning and keep building. Bye bye.